Today we're going to be looking at product of an array except self. Given an integer array nums, return an array answer such that answers I is equal to the product of all the elements of nums except nums at I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using division operation. Okay, so look at the examples real quick. So, input nums 1, 2, 3, 4. The output is 24, 12, 8, and 6. So for the first cell, it's going to be the product of everything except that cell. For cell number 2, it's going to be 1 times 3 times 4, which is 12. For 8, it's going to be 1 times 2 times 4. And then for 6, it's going to be everything but the last one. So it's going to be 1 times 2 times 3. Cool. So we do the same thing for example 2. Let's move this to IntelliJ and then look at a solution. Cool. So I have the text for the problem here. I have the two arrays that were set up for the examples. And then I have the function itself returning an array. So let's start. First, let's go into how we should approach this. I remember doing this a long time ago. Yeah, a few years ago now. And I think this one gave me a lot of issues when I first tried it. I think the biggest problem was conceptually understanding what they were asking for and then how to go about it. Right, because intuitively we could go like 1 times 2 times 3 times 4. Right, and then that'll give us the number of that 12, 24. Yeah, it's 24. Then all you would do is you would divide by the cell you're at, and then that'll give you your answer, right? It's pretty straightforward. They don't want any division. So I think I tried looking at, like multiplication, multiplying everything and then subtracting numbers or something like that. But yeah, that was just not it. It didn't click for me until I finally, I guess, went through it and then kind of realized what was actually going on. I think that's a really good thing to do during interviews. You know, you work through the problem. If you don't really understand how to go about it, try to solve it. Try to just like see the different angles you can take about it. Maybe work through it with the method they told you not to use, just to see how it would work, and then from there you can try to figure it out. So for this, actually 3 cases if you think about it. There's the leftmost, rightmost, and there's inner. Alright, so what that means is every number will fall into one of these categories, regardless of the size of the array. You'll have the number at the leftmost, the rightmost, and then the inner ones. So basically what that means, you split it up like that, it's kind of easier to understand what we're actually going to do for the solution. Just scroll down. So for the left case, so for the leftmost, the value at that cell in the output array is going to be everything on the right. Everything on the right. Then for the rightmost, it's going to be everything on the left. And then for the inner, it's going to be left and right. Okay, so this is the input array, this is the output, right? The input's 1, 2, 3, 4, and then the output's those values that we're going to go ahead and process. So for the first cell, right, it's the leftmost, so it's going to be everything on the right. It's going to be 2 times 3 times 4, which should be 24. And let's do the rightmost case, which is 4. Be 1 times 2 times 3, which is 6. And then for the inner, it's going to be everything on the left and the right. So 1 times 3 times 4, which is 12. And then we are going to have 3, which is everything on the left, everything on the right, because it's an inner. So it's going to be 1 times 2 times 4. It's going to be 8. So if we flip back the LeetCode to see the example solutions. Okay, looking at LeetCode, the output they had was 24, 12, 8, and 6. Let's go see if we got it right. Cool. And then for the LeetCode example, it was 1, 2, 3, 4, and the output was 24, 12, 8, and 6. Exactly what we got. So you want to break down this problem into the 3 cases and then go from there. I mean, if you think about it, they're all technically inner case because everything on the left and the right. It's just that for the leftmost and then the rightmost. There's no right to 4 and there's no right to 1. So it's a little bit easier to like break it down like, hey, leftmost is here, rightmost. But every single value is just a combination of everything on the left and everything on the right except itself. So let's code that out and then see how we're going to go about it. Basically, we're just going to keep track of every value to the left, everything to the right, and then kind of go from there. But yeah, cool. Now let's work on the solution. We're going to create a value to be our running counter, left counter. We're going to set that equal to 1 because when we multiply both the left and the right, if we have started 0, it'll go ahead and nullify it out, and then it'll mess with the results. Okay, so what we're going to do is we're going to set the value at the current index for the left array equal to the current counter, and then as we move right, we're going to be multiplying for each step. So let me walk through it. So left values at the current index will be set equal to the left counter, and then we need to update the left counter. Left counter is equal to left counter times the value of the original array at that position, right? So it would be nums at the current index. So for each step we're going to be updating it, it'll be multiplying itself by the value at that index, right? So at the very first it'll be 1, the beginning it'll be 1, then it'll be 2, 3, and 4. So let's do the right side. Right counter. So for this side, we're going to do it in reverse. So we're going to start instead of going left to right, we're going right to left. So integer current index will be equal to nums dot length minus 1 because we want to start at the very end, and then we want to do current index is greater than or equal to 0 because we do want the 0 value since the start of the array, and then we want to go ahead and decrease current index by 1 for each step. So just like we did before, right values at the current index will be equal to the right counter, and then we're going to update right counter to be equal to itself times nums at that position, which should be current index. And then all that's left is to multiply it out. So 4, let's do 4 integer index just to show it's different. 0 index is less than nums dot length, and we'll do plus index. So all we're doing here is setting up the solution array to be the left times the right. Cool. So what we're going to do is solution at this index will be equal to left values at this index times right values at this index, and that should be it. And then at the end, we're just go ahead and return solution. So I can remove this section here, and we should be all set. Let me add some print statements real quick just so we can see what's going on. Cool. So we're gonna call it up here, product except self, array 1, which is 1, 2, 3, and 4. Let's run it. Okay, so here is the command line. We have 1, 1, 2, and 6, 24, 12, 4, and 1, and then 24, 12, 8, and 6. So this is the solution one. We know this is correct from looking at it earlier. And then we know it's going to be the multiplication of the left, which is up here, and then the right. Cool, pretty straightforward. Let me go ahead and add the comments to show exactly what we're doing. Cool, so I just copied over from the command line. This is the left array, right array, and then the answer. So essentially all it's doing is, again, each cell is going to be equal to the product of the left array and the right array at that position. So at 0, it's going to be 24 times 1, which will be 24. Then at position 1, well, it'll be 12 times 1, it's 12. At index 2, it'll be 2 times 4, which is 8. Then at the end, it'll be 6 times 1, which is just 6. Cool, and that is the same we have as an answer. So pretty straightforward. Let's go ahead and test it now with the second array, which is over here. And the answer for that should be, I think it's all zeros except like 1, 9. Let's see, let's run it. Cool, and the solution is 0, 0, 9, 0, 0. And let's check with LeetCode to make sure it's correct. Cool, and checking out LeetCode, the answer is 0, 0, 9, 0, 0. Let's go ahead and copy that over. Cool. So here's the solution on the right, and let's go ahead and run it to make sure it works. Cool. And then submit it. Cool. 3 milliseconds, and it beats 70% of users. Okay. Not bad. Let's go to submissions and description. And then the follow-up was, can you solve the problem in O of 1 space complexity? Essentially, can I do it with just one array? It's possible. Let me go ahead and copy this over and then go into that one. Cool. So I copied it over and I just called it, I just added the no extra space. So we're gonna do this with one array. So get rid of this, and I'm gonna just get rid of all the print lines. And now we're going to have to do this with one array. So this should be fine. All we're gonna do is be updating it in real time as we go through it. So this step here will not be needed because the second step will take care of that. Essentially, all we're going to do is we're going to have the array, put the left numbers, and then once we process the right ones, we're going to automatically be multiplying. So that way we skip that extra step at the very bottom. So let's see, solution. So solution at current index is equal to left counter. Left counter is equal to, okay, it should be fine. Now this part right here. Solution at current index will be right counter times, this will actually, so solution at the current index will actually be equal to itself at the current index times the right counter. So we want to do this because these are already set up over here, right? So if we just set it to the right counter, it'll override it. We need to multiply it because that's what we're going to do with the third step anyways. And I believe that should do it. Let me copy it over. And array 2. Let me go ahead and run that real quick. Cool, let's run again. And 00901. Let me just switch it to the first array. And 24, 12, 8, and 6. Perfect. Perfect. So we should be all set. This is the one that only has one array, right? No extra space except for the one for the output. And let's copy that over and see what we get. Cool, let's run it. Let's just submit it. This should be fine. Cool. Now it runs in 1 millisecond, and this beats 100% of users using Java. Cool, I'm actually top 1. Cool. Cool. But yeah, that should be it. Any comments, questions, concerns, leave it down below. If there's any specific problem you want to look at, post it. This one's a little bit more challenging. Some of you might think it's pretty easy. I just remember a few years ago when I started doing these LeetCode problems. So it was really hard.